All right. So just to finish up, these notes should not take too long today. But basically, all we want to do is reiterate the properties of expressions, okay, and properties for simplifying algebraic expressions. One thing that is convenient to do sometimes is to deal with, obviously, subtraction. If we think about it, everything is defined off of adding. So multiplication, have we talked about this? Multiplication is repetitive addition. Subtraction is opposite, or adding the opposite. So subtraction is defined by addition. And then division is repetitive subtraction. So division is defined off of subtraction, but subtraction is defined off of adding. So everything comes back to adding, right? Okay. Our definition of subtraction just means if I want to go A minus B, that's the same thing as adding A plus the opposite of B. Okay. There are times that we go through the course that it makes most sense or more sense that when you have this written, that you actually change it to this, just so that you don't mess signs up. Okay, so we'll do that from time to time. But you can also, because they're equations, you can go both ways. Okay, so when you see an equal sign, it's a two-way street. So if you start with this, you can write it that way if you prefer, if you need to. Okay. Division's the same way. A divided by B means A over B. Okay. Or it means A times 1 over B. If I'm dividing by a value, that is equivalent to multiplying by that value's reciprocal. Okay? You guys know that if I'm in an equation and I have like 2/3 x equals 5, okay? Probably the way you were first taught to solve that was to multiply both sides by 3, and those will cancel, right? And you're left with 2x equals 15. Then you divide both sides by 2, right? Okay, you can do that. But what is easier, what is more effective, is to multiply by the reciprocal. Multiply by 3/2, multiply by 3/2, and it gives you 15 over 2 right away. Okay? So when we're dealing with division, if I want to divide by something, same thing as multiplying by the reciprocal. I worked in the last class. We had something like, this was my college algebra students, but we had something of the effect is like 7/2. And it wanted to divide by 2. The process that we wanted to go through was divide by 2. Well, if I do that, a lot of people like to write it as like 7 over 2 divided by 2, and that gets really messy looking, right? So instead of dividing by 2, we said, well, what is the same thing as dividing something by 2? It's multiplying it by 1/2. And that makes things so much easier because I multiply across the top and then multiply across the bottom. So 7 over 2 divided by 2 turns into 7 over 4. Does that kind of make sense? So dividing, same thing as multiplying by a reciprocal. Distributive property for subtraction. You guys remember distributive property just means multiply, right? So I take A times B, write that down, and then A times negative C, and I write that product down. So an example of that would be, if I talk about like 2 times 3 minus 5, okay? Take my 2, multiply by my 3, gives me 6. Take my 2, multiply by my negative 5, gives me negative 10. Now what's 6 minus 10? Negative 4, right? Okay. Now I could do this. Let's say we have 2 times 3 minus 5. Doesn't order of operations tell me to do that first? What's 3 minus 5? Negative 2, right? Now what's 2 times negative 2? Still my negative 4. So that's something we can do both ways. Usually what you see with the distributive property and where you're going to use the distributive property is if there's a algebraic variable, like in place of the 3 or the 5 or even the 2. But it can be done with just numerical values as well. Questions on that stuff so far? This all review? Okay, good. Multiplication by 0, hopefully we know that anything multiplied by 0 is 0. 0 times 0 is 0. 0 times any number is 0. Multiplying by -1 to any number gives me the opposite of that number. Okay. It's called opposite of a sum, but we can view it as a property that we already know. Instead of putting that negative out front, I can actually make it a -1 out front. If I take a -1 times A, does that give you negative A? And if I take -1 times B, does that give you a negative B or minus B? Does that make sense? So I call it an opposite of a sum and an opposite of a difference, but these two are just distributing a negative through, which if we understood the distributive property, that's an easy extension of that. Same thing down here. Okay. Distribute a negative to a product. So this is like, if I had something like that, well, that's a negative. I can write that as -2 times 3. I can write it as 2 times -3, or I can just write it as the opposite of 6, but they all equate to -6, don't they? That's all that's saying. Okay. And then the opposite of an opposite is positive. Two negatives being multiplied together give me a positive. Okay. Are those rules that you guys are familiar with, you're comfortable with? You guys are silent, quiet. Okay. So what we're talking about then, like, is it confusing because using the letters? Okay. Is there a way that I can fix that? I can see where you're coming from. I agree. When I was in classes that they're talking about these rules that are important for us to learn, but it didn't really make a whole lot of sense, or I didn't pay a whole lot of attention until we started seeing specific examples, right? And then it starts to maybe I get more involved. So the one thing I want to make sure we understand, though, is, like, depending on where we go from Algebra 2, whatever our next class is going to be mathematically, there will be instances where we're just doing math based off of letters in our operations, okay, or symbols in our operations, and not so much specific values. So I think it's important, the better you know these and the easier you can navigate these, it makes these specific examples a little bit more concrete, okay? Why don't let's do a couple of these examples together, and then I will give you some time to do the other examples on your own, and then that should free up some time to complete the assignment that's open if you have not done so far. Let's do 16 together. Okay, so this first one together. If we have, just to make it easier for me to write, I'm going to cut and paste this over here. All right, so in this situation, all they're going to do is ask you to evaluate. So from yesterday, we were talking about if I have 4A, but now A is -5, we're going to replace that. Plus then 7, but B is 3. Plus then 3, A again was -5. Minus 2, B again was 3. Plus then 2, but A again was -5. So all those properties that we just mentioned, they exist here because one of those properties was like when we had like a -A like that, we write that as negative A. It's the opposite of a term, or the opposite of an opposite, okay? Some of those things might exist here. In a moment, we're going to have, this is going to be plus A, supposed to be like 21, and this will be plus then negative 15, and we'll see plus a minus, we can override that to just subtraction. So there's going to be properties as we start simplifying that we mentioned above that we're going to see multiple iterations of or examples of inside these specific values. So PEMDAS, are there any parentheses in which we can work inside those parentheses? No, they're all individual, just implying multiplication, right? So let's go ahead and do all our multiplication left to right as we multiplication division left to right as we see it. So that's going to turn into negative 20, right? Okay. Now traditionally, like the way that you're supposed to really do this is that you do one calculation and then everything else stays the same. Okay, and if you think about this, is that going to be a long, tedious thing to do? Okay, so if you've got multiple instances of multiplication and or division occurring, you can, and they're attached through plus and minuses, you can go through and evaluate them all at the same time. So negative 20, got my plus sign, bring that down, 21. Got my another plus sign, bring that down. What's 3 times negative 5, or negative 5? Negative 15, right? Okay, and I like to put it in parentheses when it's negative, but you don't have to. And then it's going to be minus, so negative 2 times 3 is negative 6, and then minus then 10, right? Now this is one of the operations that happen above. Okay, remember we had a plus or minus. If I go back to our rules above, that was the definition of subtraction. If you have we have the right-hand side here, plus a negative b, you can rewrite that as a minus b. So down here we have plus a negative 15. A lot of us are probably going to rewrite that as negative 20 plus 21. Now minus 15 minus 6 minus 10. And now it all breaks down to adding and subtracting, right? So order of operations, if it's adding and subtracting, what you can do is you can go left to right and just keep a running total of what your sums or difference are. Does that make sense? Or if you want to, you can use the commutative property and associative property and group things that might allow you to add things a little bit better. So here's just keeping a running total real quick. If I go negative 20 plus 21, running total, that would give me 1, right? Minus then 15, running total, all that would give me negative 14. Minus 6 again would give me negative 20 as a running total, and then minus 10 gives me a total of negative 30. Is that okay with everybody? Okay. Now, the purpose of the associative and commutative properties are this. If I have positive 21, and that right there, okay, so it's a positive. If I group that stuff right there, what is 21 minus 15 minus 6? Or even go further and group those two. What's negative 15 minus 6? That's negative 21, right? And then is positive 21 minus 21, are those additive inverses eventually? Does that kind of make sense to everybody? So that's maybe the purpose of understanding the commutative property and the associative property, because now it just leaves me negative 20 minus 10. Negative 20 minus 10 is negative 30, right? And if you can see little things like that, that might help you be more efficient than keeping that running total of minus 20 plus 21 minus 15 and minus 6 more, minus 10, and getting negative 30 that way. They're both fine. They both work. And maybe the first technique might take 15 seconds to do, and the second one might take 8 seconds to do. In terms of seconds, it's not a life changer. But in terms of mathematics in general, a lot of the rules and procedures that we go through in mathematics, they're designed so that we can use them to be efficient. Okay. You guys ever it on a computer program. You do it with your laptops all the time, and you log into a website and you want it to be instantaneous, but you've got to wait a little bit for it to load. And sometimes it's the network, but sometimes it's the website. Okay, and the way the website has been designed, the mathematics behind the website is not efficient. Where if they go through the mathematics and the background and the coding, and they clean some of it up and use more efficient procedures, that website will load a lot faster for you. Okay, so our technology, when you get like slow responses from your technology, chances are it's because the mathematics that is used to program that technology isn't programmed as efficient as it possibly could be. Okay, and that's why companies like Apple or Microsoft, they come up with like new iOSs and new, like every once in a while they'll come out with a fix for a bug or something like that. That's what they're doing. They're trying to make things more efficient in their coding for their users. Let's try this one. Remember and this is where people get confused, the signs that are in the original problem, the original expression, they cannot be changed. So this negative has to stay, even though I'm bringing in another negative for k. Okay? So now when I replace that k right there, I'm replacing that k, because I'm replacing it with a negative number, I'm always going to put it in parentheses. And to be honest with you, I even do it when there's exponents, I do it with positive numbers too. I just want to make sure that I get the correct sign through my order of operations. So now this minus sign needs to stay. Then we have our 3. I'm going to put k in. Now here's the thing. If I don't put parentheses around the k when I put it in, I just put in -1. What's that look like I'm doing? 3 minus 1, right? But 3k means I should be multiplying by -1, right? So that's where, if we don't follow those types of procedures in our handwriting, we can get ourselves into trouble. So when we make those substitutions, that's kind of the most concise, cleanest way we can write those. So now order of operations tells us we need to go find parentheses. And when we go through parentheses, there's parentheses here, but there's nothing I can do inside them. Get over here. Now, that parenthesis and that one does have stuff inside, right? Okay, so I'm going to now attack this problem just focusing on the green stuff. Okay, I'm going to ignore everything else that is there. Just going to work on the green. And now once I'm inside the green stuff, I'm going to do the order of operations again. Okay? So looking at the green stuff, are there more parentheses inside here that I can do? Well, there's 2 sets of parentheses, a -1 here and a -2, but there's nothing else in there that I can combine that with, right? There's no operations to do in there. So no more parentheses. There are no exponents in the green stuff. Is there multiplication in the green stuff? Is that multiplication? So let's do that. So I get -3. Is this multiplication? Okay, so what's 5 times -2? -10, right? That's the product. Now, you can do one of 2 things. You can leave that minus sign here, or when you multiply these, you can make it -5 times -2. What's -5 times -2? +10? Would you agree with that? Okay. Or I can write it this way, and what's minus a -10? Doesn't a minus a negative turn into a positive? So regardless of how I do that, this here is going to simplify down to +10. Okay with everybody? And that parenthesis right there and that parenthesis right there are still existing because I haven't combined everything inside yet. So what's -3 + 10? 7. Okay. So, working in order of operations, and I identify my parentheses, I have worked inside those parentheses with the order of operation enough to get down to a singular value, right? So this green stuff is gone. This green stuff is replaced with 7. I'm going to rewrite all the other blue stuff from the original problem that we didn't touch at the onset. And that's the idea of running through your order of operations inside your first set of parentheses that you can do something, okay? That problem now, it's the same as what we started with, but it's a little bit cleaner. It's a little bit less messy. Now I'm going to go through order of operations again. So I go look for parentheses. There are no parentheses that we can do anything with, but there are exponents, right? What's negative 1 squared? Positive 1, right? Okay. So this negative sign stays. This here is what I was doing, and that becomes positive 1. So a negative in front of a positive 1 turns into a negative 1. Then I've got my minus 7 and plus 4 times negative 2. Run through order of operations again. No more parentheses, no more exponents. Is there a multiplication existing here? So we get negative 1 minus 7. Multiplication here turns into negative 8, right? Go through order of operations again. No parentheses, no exponents, no more multiplication, no more division. There's no adding, but there is subtraction, right? And now, because it's all subtraction, I just go left to right. Negative 1 minus 7 is negative 8. Minus 8 again, negative 16. Okay. Now, there will be times that I ask you for work. I want you to show me that work, okay? But there are also times that maybe we're doing this simplifying, this evaluating to get to something more difficult. Maybe it's an intermediate step in a problem, okay? So in order to maybe circumvent some of that work, I want to show you how you can use some calculators to help you out with this, okay? If you guys go to Desmos, you can get your computers out if you want, but we're not going to spend a lot of time on it. I'll just show you how to do it, and then you can use this on your own. My suggestion, like I would use this to check all my homework, okay? I'm going to type in, so I go to Desmos, scientific calculator. I'm going to type in exactly what I saw here in my problem. So I'm going to go negative k squared minus, and then 3k minus 5n plus 4n. Okay? I want to hit enter, and you notice that when I hit enter, it gives me this little error here. It just tells me I have too many variables, and I haven't told anybody what those variables are yet. Okay? I'm going to come down to the next line. I'm going to hit K, and we'll hit equals. And we said K was going to be negative 1, right? So I'll type in negative 1. And then we'll hit enter, go to the next line, and I'm going to type in what N was. N, what do we say N was? Negative 2. And once I evaluate everything, okay, so the calculator is taking those numbers, plugging it in, and then get negative 16. And that's what we came up with down here, isn't it? That kind of makes sense? Okay. Now, if you have does anybody have, you guys all should have this calculator on your computers. Okay. If we don't, we can work one of these days and getting it for you. But if you guys take the ACT, okay, which juniors, right? A lot of us, okay? You can take the ACT later in the year. This is the calculator you have to use. Well, if I have something I have to simplify things on, it would be nice to be able to do the exact same thing I just did, okay? So what I'm going to do is I'm going to type in negative. Now, if I hit alpha, it's going to allow me to bring up these letters here that you see on my mind. They're green, so we used K. and I'm going to square it. Go back to the problem. And I'm going to hit minus 3, and I'm going to hit alpha again. Find my K. Should have put parentheses around that. So I should have put a parenthesis there. And then minus 5, I'm going to go alpha N. And then I'll hit plus 4. And then alpha N again. Okay? So it should look something like that. Now, I'm going to hit enter, and it gives me 0. And if you were doing this on yours, it would probably give you a completely different number. Sometimes it would give you error, whatever. It's just because there's values that are stored for K and N right now that are not what our problem says. So what I'm going to do is I'm going to hit alpha. Actually, I got to do it this way. What was the K was -1. So you got to hit -1. You see this button right here that says STO? That stands for store. So I'm going to store that, and I'm going to hit alpha K. And I hit enter, and it just puts the number that I was storing. And that's exactly the same as what we were doing here in Desmos when I said K was equal to -1 right here. Okay? Just the steps are a little bit more involved on this calculator. Now I'm going to hit -2, and I want to hit STO, and I want to store that as N. Okay. So now this was my original problem, and Desmos automatically, whenever it saw this, it would go back up here and reevaluate. The TI-83 doesn't do it that way. I actually have to type this in again, but the easiest way to type it in again is to hit second enter and keep doing that. It remembers the last 10 things I typed in. So I can go second enter. Eventually it comes back up to this. If I hit enter, it'll show me my -16. Does that make sense? Okay. So when we have things in class that we can use our technology to help us out a little bit, I'm going to show those things to you, and I'm going to show them to you in varying formats, varying technologies, Desmos, TI-83, because Desmos you're going to be able to use whenever you want to on your homework, that kind of stuff, right? Tests, quizzes. TI-83 you can use anytime you want to as well, but on your ACT, that's the only calculator, or I guess that's the highest level of calculator that they let you use. Okay, they don't let you use Desmos on the ACT. So just kind of keep that in mind. We talked about like terms. Someone jumped down to these examples here. We talked about like terms the other day. Like terms have to have the same variable and same exponent. So I think we saw some examples, like if I said like 5xy and 7xy, those are like terms because they both have an x and they both have y, right? Now they have the same exponents, okay? The x's and y's do. So if I did something like this, if I said 5xy and 5x squared y, they're the same variables, correct? But because that exponent right there is different than the exponent right there, they are not like terms. Every variable has to be the same with the exact same exponent. So that's something to keep in mind, which will become a huge concern in this class later on. But let's go ahead and do a couple of these. What is this first one here? What's that going to combine to? 5a minus 1a. 4a. What about, let's just go to 33, or 31 here. What's that going to combine to? Okay, 2s plus 5. Can I write that as 5 plus 2s? Yes. What's the next one going to combine to? 6a plus 3b. 34. 5s plus 10r. This one here, we just got to, I suggest doing this. 7b, distribute your negative, so it makes a negative 3a. and then plus 8B. So if I'm doing that, how many B's? Good. Now here, because this is a plus sign, if I distribute a positive, these signs don't change at all. So what they're doing here in this problem is unnecessary. They could have just written it this way. They don't need the parentheses. You guys agree that's 4G minus 2? Okay. Let's do at least one of these down here. It says, write an algebraic expression to model each situation. Okay. First one says the freshman class will be selling carnations as a class project. What is the class income after it pays the florist a flat fee of $200 and sells X carnations for $2 each? So income, after it pays the florist a flat fee of $200. Okay. When we do one of these problems, the first thing we should do, and they do it for us here, but is identify what our variable is. So I'm going to say let X equal number of carnations. Okay. X equals number of carnations. And then oh, wrong color. Just trying to give myself some more room here. Okay, so if I let X be, I don't know why that does that all the time. X equal the number of carnations, okay? How much money am I making off of each carnation? $2. So if I sell one carnation, I've really made $2, right? If I sell two carnations, I've really made $4. 3 carnations would be 2 times 3 is 6, right? So these numbers are staying the same. That's the amount of money I'm making off of each one being sold. So I'm going to write 2, and these are changing, right? The 1, the 2, the 3 that changed, that's the number of carnations that I was selling. That's my variable. So 2X represents how much money that I'm making off of each carnation, right? Okay. Now, if I'm paying a flat fee of $200, is that money that is coming in or is that money that's going out? It's going out, right? So is that additive or subtractive? Subtractive. Okay, so I'm going to remove $200. And that should be my expression then for determining how much money we've made. Okay, how many carnations do I have to sell to break even? To just pay the florist. Got to sell 100, right? Okay. Then after everything after 100 is then going to be profitable for me. Okay. So we'll stop there. The plan for tomorrow, folks, is to